So good morning, everyone. Uh, I think it is audible now and visible as well. So I'm Professor Ujjwal Shirode. Today I'm going to host this session, that is day 3 of this particular STTP. And as the theme of this particular workshop is of practical approach towards electronics and telecommunication engineering. So in view of this practical approach, we know that the sensors, actuators, PLCs, Arduinos. Yesterday, we learned something about Arduino. What is the importance of controllers, Arduinos in view of electronics branch? So, in continuation of that, can we go with the industry applications? Can we have the industry tabs so that our student and not only student ourselves can learn the industrial application, can work on industry projects through this particular basic electronic concept like controller, Arduino, and PLC. So, in view of that, Pimpri Chinchwad College of Engineering is closely associated with Innovative Solutions Private Limited, which is located at Bhosri, Pune. Pimpri. So we have tie-up. We have made make MOU for development of Mechatronics lab. Under that Mechatronics lab, we develop many kits for students, and uh, this in this particular MOU, faculty as well as student gets internship as well as sponsored projects, and through which we learn many advanced technologies using PLC and all this technology. So I'm happy to share you that one of the person from Innovative Solution, Mr. Shubham Sonigra, is with us today. So he's going to deliver today's session. So what is Innovative Solution? How Innovative Solution can help out you people also, and how the sensor can interface with Arduinos, and how one can switch from Arduino to PLC. What are the different industrial application? What are the different industrial areas where we as a technical staff, we as a faculty, we as a student can help to industry and can take a help from industry. So from now I'm going to hand over this session to Mr. Shubham Sonigra. Welcome, Mr. Shubham from Innovative Solution. So I
Thank you very
hope
much.
it is audible, Shubham.
Yes, sir, perfectly audible.
Okay,
Thank you
so
very
I'm
much for
going
the
to hand
introduction.
over this session to you. Okay,
Okay,
thank you.
okay. Thank you very much, sir. And thank you, PCCI, for this opportunity. So, firstly, I will introduce about Innovative Solutions India Private Limited, previously which was known as Innovative Solutions. So, Innovative Solutions is a automation company which was founded in 1999 with the aim to cater the services and deliver automation solutions to the industry. And our vision is to be a preferred and leading automation solution provider. And we are a very philosophy based company, so we are very customer centric. We follow ethical business practices, and as the name says, we have a lot of innovation in our work, and ultimately sustainable development should be the goal for everyone. We have a huge setup. You can see it's around 24,000 square feet setup, manufacturing setup in Bhosri MIDC, and we have our offices in Nasik, Aurangabad, and Mumbai, but our headquarters is located in Pune, which is in Bhosri. We have a staff of around 60 people. So currently the staff is of 75 people, and in which over 40 people are engineers and 20 people are support staff. See, these are some of the standards which we follow. So we are ISO 9001 2015 certified organization for best automation and quality purposes. And we use all the standard softwares like SAP B1. Then ePlan is an electrical design software. You may be aware of softwares like Multisim or Spice and all. So this is a similar software, but it is used for panel design and electrical design on a larger scope. And these are some of the manufacturing processes, which is IEC 61439 and IEC 61131, which is again programming software. So we have our business alliances with some of the leading companies in the world. So we have been working with Mitsubishi Electric for past 20 years, and we are the leading system integrator for Mitsubishi in India. Then again, we are working with this Japanese company known as Nidec Shimpo. So they manufacture all the gearboxes and all. So Cognex is an American company which manufactures vision systems. So all the industrial vision is supplied by Cognex. It has a large share in industry. So cameras, barcode readers, 3D scanners, and all these things are manufactured by Cognex in America. And again, Banner is an American company which manufactures sensors and advanced data acquisition systems. It is like they manufacture sensors with wireless capability and great sensing range. Then Boner is a power distribution system. Boner manufactures bus bars and all these things. Just a minute. Yes, sir. Okay, sir. Okay. Yeah. So saying about Boner. So generally in industrial systems, we require power transmission of high current capacity. So this may be in 1000 amperes, 20,000 amperes. So we cannot use regular cables for that. And for that purpose, we are using Boner power distribution systems where the power transmission requirement is very high. So these are some of the solutions which we cater for various industries like pharmaceutical industry, packaging industry, robotics, material handling, and factory automation. Industry 4.0 is a latest trend in industry where uh, connectivity is the important feature where we can do the visualization, then data acquisition, and all the fancy things like cloud computing and all these things are a part of industry 4.0. Just some of our customers, like we're working with really large customers like Bharat Forge, Bajaj, Thermax, KTM and all, Maruti Suzuki. So we are working with them very closely on their projects. This is the product range. I mean, it's not very important in this, but I'll still go through it. So this is the product range by Mitsubishi. So Mitsubishi is one of the leading manufacturers of PLCs, servos, HMIs, IPCs. Then again, VFDs are used everywhere. And recently, a few years ago, Mitsubishi has introduced their range of industrial robots in India, and we are working with them. So again, vision systems by Cognex, power transmission systems by Nidec Shimpo, sensors and indicators and all these things. You can say this human machine interaction. So these systems are supplied by Banner, and this is the power transmission, power distribution system I was talking about by Boner. These are some of the photos of the company. So you can see all these projects are done using the highest standards in the industry because they have to be very reliable and long life. So Innovative Solutions has been the #1 channel partner all India for Mitsubishi Electric for past 6 years, and we are currently the leading channel partner for Mitsubishi in India. So in January 2020, we signed an MOU with PCCOE for this purpose of research and skill development. So PCCOE and Innovative Solutions can jointly work on some important projects, and we can both share knowledge, and so the students can get benefited, and even the company can get some academic expertise from PCCOE. So we'll get back to the topic of this session, which is mechatronics. So these are the contents. So first we will discuss why mechatronics, what is mechatronics, components of mechatronics, then we'll move on to sensors, then drive elements, and finally control elements. So basically, what is mechatronics? So what does mechatronics sound like? It is the combination of words like mecha and tronics, which is mechanical and electronics. So mechatronics is a multidisciplinary field which combines several fields of engineering like electrical engineering, computer engineering, and mechanical engineering. So it refers to a skill set which is required in advanced manufacturing and automation and all these industries. So basically, no system is standalone. So currently, in the current scenario, there can be no machine which only works on mechanical or only works on electrical or computer. So every machine is a combination of all these things. So basically, that's what mechatronics deals with. So it is dealing with everything which is controlling the machine, which is operating the machine, which is writing the logic of the machine, and which is visualizing the machine. So you can see this Venn diagram where it is shown that it's a combination of computers, mechanical, electronics, and control systems. So why mechatronics? I mean, why cannot any machine be only mechanical or only electrical? So previously in the old days, all the machines were driven by mechanical systems like camshafts and engines and hydraulics, but they were very inefficient. And for even for a small change, you had to make a large investment. But due to the advanced electronics technology, people started replacing the mechanical elements with some electrical elements. So machines became more and more versatile. But after that, there were some problems in the electrical elements. I mean, electrical elements cannot be standalone. So then came the age of controllers and PLCs. So people started customizing their machines as per their need from time to time. So the investment in changing the machine drastically reduced. So then a machine became a combination of electrical, mechanical, and computer technology. So that is why when we talk about mechatronics, we need to forget that we are electrical engineers or mechanical engineers or computer engineers or any type. So this field is dealing with all the branches, and it takes a very multidisciplinary or interdisciplinary approach to understand mechatronics. So what are the basic components of mechatronics? As the word says, it has mechanical, then again electromechanical is a combination of electronic and mechanical components. For an example, you can give the input as an electrical signal and the output will be a mechanical movement. Then we need electrical components, we need computing technologies, you need control hardware, and finally the software elements. So these are some of the components of mechatronics. So what are the mechanical elements in this? So mechanical elements refers to the mechanical structures, mechanisms, thermofluid, hydraulics, and all these aspects of mechatronic system. So even, I mean, you can take a simple example. So every machine has a frame. So no machine can stand without a frame. So that frame is the mechanical element of that mechatronic system. Then hydraulics. So everyone has seen what a crane looks like. So every crane, I mean, the movement of the parts of crane are done by hydraulics. So hydraulics deals with a large amount of energy flowing through hydraulic fluid. So these are the basic definition of mechanical elements. So it can be a cam, it can be an engine, it can be anything that moves. Any element that physically moves can be considered as a mechanical element or electromechanical element. So again, electromechanical elements. So electromechanical element can be sensors, actuators, anything that deals with the conversion of energy from electrical to mechanical or mechanical to electrical. So it can be a actuator like this shown in the left corner of the slide, or it can be a sensor which is in the middle, or it can be a motor. So in the first example, it is converting electrical energy and then using pneumatic power to actuate. So the walls and all are actuated electrically, but the motion is taking place mechanically. Then we have sensors. Sensors are converting one form of energy into an electrical signal which can be interpreted by the machine. And then we have motors, which is again a complete electrical system and completely electrical, and electrical signals are converted into motion with the help of electromagnetism. And anything, I mean, almost all elements around us are electromechanical elements, right from the microphones, speakers, relays, and everything. We are filled with, our life is filled with electromechanical elements, right from a mobile phone to the ceiling fan, ACs, lifts, cranes, and all these things are electromechanical elements. Then electrical or electronics, these can be electrical components like resistors, inductors, transistors, transformers, and anything which deals with electrical signals. So these are dedicated, I mean, these are only electrical components, like they do not have any moving or mechanical parts. So mostly all these electrical devices are used in support with the mechanical devices. So, I mean, there is no use of a servo drive without a servo motor, or a slide drive without a slide. So these are used to drive the mechanical elements. So all the elements are interdependent. Then finally we are talking about the control interface or the computing hardware. So this is the heart and brain of the machine. So every machine has its own logic, and that logic is written in these devices. So in the left side, you can see a PLC, which is used in industry. And on the right side, you can see Arduino, which is used for rapid prototyping and academic projects. So both the functionality of both these devices is same, and they have only one purpose, that is to control the machine. This is the last part, which is a new trend, or you can say this is the latest technology in electromechanical systems, or you can say in machines or in mechatronics. So it's just computing. So what happens in computing is that the logic implemented in the controllers or the Arduino or PLC, so they are taking care of the machine. But what about visualization? How will the person sitting outside the machine will know what is happening in the machine? So that is done with the computing elements or the computing softwares. So they are giving us an insight of what is happening in the machine, what should happen, and what could possibly go wrong. And again, it takes care of data acquisition. So if suppose there is a problem today in the machine, the problem may not be arise due to some immediate problem. It may be from past few days or past few months. So we need to have the data of the machines for past few months. So that is taken care by the data acquisition system, which is storing the data of the entire machine and deriving meaningful outcomes from that data. So this is taken care by the computing hardware. Now we'll talk about sensors. So basically what a sensor is, it is nothing but it converts the physical parameter into an electrical signal which can be measured, because we are all feeling temperature around us, we can feel humidity, we can see things, everything is visible. I mean, the parameters are all around us. We can see this, we can feel them, because they are in a form which we can sense. You cannot sense the temperature of a gas cooker, of a cooker just by sitting far away from it. You need to be close. The signal needs to reach to you, and only then you can sense it. So what needs to be done is that the parameter which has to be measured needs to be in a meaningful form. Now, you cannot understand a temperature in millimeters, or if a water, I mean, you cannot give the definition of temperature in millimeters or in kilograms. It has to be in degrees Celsius or Fahrenheit. So that is the meaningful way. Similarly, a sensor cannot give random signals. It has to give signal which can be electrically measured. So that's what a sensor does. It converts the physical parameter into a signal which can be electrically measured. So there are various types of sensors and various forms of sensor. A sensor can be as small or as a transistor, or it can be as small as a diode, and from that it can be huge like these industrial sensors. So depending on the application, various types of sensors are selected. So you can say that there are at least 10 to 15 different sensors embedded in our mobile. But when we talk about industrial sensors, each sensor is bigger than our mobile. What are the various types of sensors? So, I mean, classifying the sensors is very difficult. So we can broadly classify them into two types: digital sensors and analog sensors. So you can, it is self-explanatory that digital signal will give you signal only in the form of 1 and 0. Either it is there or it is not there. So it can be a proximity sensor. Proximity sensor will tell you if an object is there or it is not there. Limit switch will tell you if it is on or not on. Color sensor will tell you if it is red or it is black or it is not that color. And then we talk about analog sensors. So analog sensors are used to measure a particular parameter. So analog sensors will not just tell you whether it is there or not, it will tell you how much it is there. It will talk about the quantity, not just about the presence or absence. So suppose it is a temperature sensor. So it will not just tell you whether it is hot or it is not hot. It will tell you what is the temperature of the sensor. A gyroscope will tell you how tilted it is. It will give you the position in XYZ. And again, the pressure sensor will give you the amount of pressure that is exerted. It will not just tell you whether it is high pressure or low pressure, but it will give you the exact value of that parameter. Signals can be again classified depending on the output. So if it is a digital output, it can be a transistor output or a relay output. So in a transistor output, you can say that it is a, you can take an example of a proximity sensor. So a proximity sensor can give you output as 24 volt when it is sensed, or it can give you output in 0 volt when it is sensed. So it depends on the selection criteria what you're looking at. So if you want output as 0 volt, then when the sensor is not sensed, then it will give you 24 volt. And when something comes near the sensor, then it will give you 0 volt. And quite the opposite in the other type of sensor. Again, we have relay output, which means when the sensor is on, the relay will be on and the circuit will be closed. And when the sensor is off, the relay will be off and circuit will be open. Then we talk about analog output current. So generally in industry, current source and current sink are very common types of sensors. So what they do is that they will give you a constant current value. So generally 4 to 20 milliampere current range is used in the current type of sensors. So suppose a range of a sensor is 0 to 100 degrees Celsius. So when it is corresponding to 100 degrees Celsius, the sensor will give you 20 milliampere. And when it is 0 degrees Celsius, it will give you 4 milliampere. So that is constant current, or you can say analog current output sensor. Then we have constant voltage or analog voltage sensor. So again, this can give you voltage in the range of 0 to 10 volts or 0 to 24 volts. So as the parameter changes, the voltage changes. And then we have analog resistor. So we know RTCs, which is resistor temperature coefficient. So these are the temperature sensors whose resistance changes as per the parameter changes. So PT100 is a good example of that. Then some of the sensors, I mean, analog output is not possible for all sensors. So gyroscope is, you can take an example of gyroscope. So gyroscope is measuring multiple quantities. So it is measuring the tilt in x-axis, y-axis, z-axis. Then some sensors have gyroscope and accelerometer, which is the ADXL sensor. So it will have both, it will measure both the tilt and the acceleration in each axis. So there are multiple quantities which has to be measured. So it is not possible to give the signal in form of just the analog voltage or analog current. So what it does is that it processes all the signals and communicates with the PLC via serial communication. So it can communicate via UART or 232 or I2C. So these are the communication based sensors. So communication can be Ethernet based, can be a serial communication, or it can be a wireless communication. So in uh, in large plants and large industries, it is not possible to wire every sensor. So what they do is that they place the sensor at various places, and there is a central wireless receiver, and the sensors wirelessly communicate with the controller on the wireless transceiver. So this is the classification of sensors and depending on the communication signals. So yeah, how do we select a sensor? I mean, what parameters do we look up to while selecting a sensor? The most important thing, or one of the most important thing, is accuracy. So what is accuracy? So we can say that accuracy is how close the sensor is to the actual value. So suppose I mean, we need to have a reference value for measuring accuracy, but suppose we have a reference value. Suppose the temperature of an object is 50 degrees Celsius and the sensor is measuring 50 degrees Celsius. So you can say that the sensor is highly accurate. But if the sensor is measuring 40 degrees Celsius and the actual parameter is 50 degrees Celsius, so you can say the accuracy is not that much. Then again, we need to understand the environmental condition. So suppose you're working in an open environment and you have temperature sensors all around. But suppose there is a rain or it is a humid environment like Mumbai. So in such cases, the ordinary sensors can get damaged very easily because they are not made for that environment. So we also need to understand what environment the sensor is designed for. So it can be the IP protection, or it can be the current capacity, or it can be the shielding and all. So we need to understand the environmental condition while selecting the sensor. The next parameter is the range of the sensor. So, I mean, if you're measuring the temperature of a human body, you do not need to have the range of the thermometer to 100 degrees Celsius because that is not the ideal range. So what we do is that the thermometer which we used, the mercury thermometer which we use, the range of that thermometer may be from 90 to 93 degree Fahrenheit to 108 degree Fahrenheit. So that is the range of that sensor. But if you're measuring the temperature of a furnace where the temperature can go up to 800 degrees Celsius, then there you cannot use the mercury thermometer. There you need a different type of sensor with different range. So range is again an important parameter because if you miss the range or if you take the wrong range, then you will never get the proper outcome. Then again, there's calibration. So every sensor has to be calibrated according to the references. So you need to know what are the values of the sensors or what are the outcomes of the sensors with in reference to standard values. So you need to calibrate the sensor for its range with some references. So you need to know that yes, this mercury is going up to, you can say 10 mm or 100 mm for this amount of temperature, and that once the sensor is calibrated, the sensor has to give the same output every time for the same parameter, which means if it is expanding by 10 mm for 95 degree Fahrenheit, it should expand for 10 mm for every time it is measured with 95 degree Fahrenheit. Then we talk about the resolution. So resolution is the minimum smallest increment detected by the sensor. That means if you can say the resolution of your temperature sensor is 0.1 degree Celsius, which means the smallest increment it can measure is 0.1 degree Celsius. So suppose the temperature changes by 0.05 degree Celsius, the sensor cannot read it. So that is what resolution deals with. Then we have cost. Cost can be an important factor when we are talking about sensors in large quantities. And again, in microelectronics, where we need to fit thousands of sensors in small spaces, we need to talk about price and the cost, and again repeatability. So as I said previously, the sensor should give the same outcome when measured under the same environment. So if the reference temperature is 95 degrees Celsius, then the sensor should show 95 degrees Celsius every time 95 degrees Celsius comes near it. These are some of the common sensors. Like we talk about temperature sensors. Then what are the temperature sensors? We have thermistors, thermocouples, RTDs, IC-based sensors, and we have pressure sensors. So the pressure sensor can be fiber optic sensors, it can be vacuum sensors, it can be valve-based sensors, and we have LVDTs, we have flow sensors, we have level sensors, proximity sensors, then again image sensors. So all our cameras have a CMOS sensor, which is an image sensor. We have gas sensors, accelerometers, and I mean every parameter which needs to be measured, there is a sensor for that. Right from temperature to vision to gas. I mean, as we smell an object, that smell can be detected by gas sensors. So there are gas leak detectors which can detect if there is a leakage in the household gas. Then we have flow sensors which will measure the flow of a liquid or a gas. Then we have pressure sensors which are used everywhere. And even the touch screen of our mobile phones, all even that is a sensor, that is a capacitive display. So if you touch your mobile with a metal object, it will not sense if that it has touched. You need to touch it with your finger. So that is an example of the capacitive sensor or capacitive display. So we'll talk about temperature sensor. So the reason of taking this sensor is that it is very widely used. In almost every application requires a temperature sensor because temperature is an important parameter in the operation of an electronics. So every electronics device has its own temperature sensor, right from the mobile phones to the motors and all, because they cannot operate beyond a certain temperature. So they need to know how the temperature is changing. So I mean, this is a very interesting point because previously we were all using the mercury thermometers at our homes to check fever and all, which was the contact sensors. So the mercury thermometer is coming in contact with our body, and then it is giving us the value of the temperature. But in the current pandemic COVID situation, everyone is using the contactless sensor, which is it is just like the just like a small gun, and it is sensing the temperature of your forehead. So it is a non-contact sensor. It is using Planck's law, which is it is measuring the radiation from the body, and it is measuring the temperature. So it is an example of non-contact sensor. So you don't need to touch the body which you're measuring. What are the various working principles of common temperature sensors? So first of all, we'll talk about thermocouple. So what happens in thermocouple is that it is made up of two different materials or two different alloys, and they are joined together. And what happens is that different I mean, depending on the material, different current flows in different material at different temperatures. So every material or every substance has its own temperature characteristics. And when we are connecting two metals or two alloys of different characteristics, there is some potential difference generated. And this potential difference is measured. So the main working principle here is that we are exploiting the different current flowing capacities and the different temperature characteristics of two different types of materials. And then when it is exposed to a temperature, there is a flow of current. And we are measuring this very small flow of current in thermocouples. Then we have RTDs. So what is RTD? So basically it is resistance temperature detector. So what RTD does is that it changes the resistance as per the temperature. But I mean, there's a difference between RTDs and thermistors, even though they sound same. So it can be a non-linear change in temperature, or it can be a linear change in temperature. And RTDs are very commonly used in industry because they are very reliable. And then we have thermistors. So depending on the thermistor, there's a large change in resistors when there is a large change in resistance corresponding to small change in temperature. So the RTDs and thermistors can be finely classified depending on the range, the sensing capability, and the reliability and the accuracy. So you can see PT100 is a classic example of RTD, and PT100 is widely used. It is a platinum sensor. Also, it is very expensive, but it is also highly reliable. So this is used in all the industrial environments where we need to measure temperature very accurately and reliably. Then we have this thermocouple. So you can see in thermocouple, there are two wires of different types. So say wire A and wire B. So when there is a temperature difference between the hot junction and cold junction, there is the potential difference is generated due to the different characteristics of the two wires. So it is so you can say that this thermocouple is generating its own voltage. So unlike other two types of sensors, RTDs and thermistors, we do not require any additional voltage in thermocouples. So it is generating its own voltage. And then again, LM35 is a very common temperature sensor. It is a thermistor, and it has an instrumentation amplifier inside it, which is again, it is giving output in the form of output voltage when we supply input voltage. This is the comparison of various types of temperature sensors. So it can be a thermistor, thermocouple, or RTD. You can see they have a very different operating range, different operating environment. Accuracies are different. Reliability, cost, everything is quite different. So we can select a sensor depending on the application. So for a particular application, I mean, depending on the if it is an industrial application, it has to be very reliable. So that is the reason we are using RTDs in industry, which is rarely susceptible to noise, and it is slow, but it is reliable. But thermistors, where we require instantaneous reading, we are using thermistors where we require instantaneous readings, like in our mobile phones or in the contact temperature sensors. So we are using thermistors in such cases. And also it is low cost, so it can be used everywhere. But on the other side, thermocouple cannot be used in daily life or every application because the starting range of a thermocouple is quite high. So if you need to measure the temperature, which is in range of 100 to 50 degrees Celsius, you cannot use the thermocouple. You need to use a thermistor or or an RTD. So basically you can select a sensor depending on the requirements. Proximity sensors. So now probably very few of us or very few of you may have widely use this sensor because it may not look like a sensor. It will just give you an output like 0 or 1. So what a proximity sensor does is that it will tell you whether an object is near it or it is not near it. So whether the object is in its proximity or it is not in its proximity. It is a very simple operation. So you don't have to measure anything. You don't have to measure the distance. You don't have to do any measurement. You just have to tell whether the object is nearby or it is not nearby. These sensors are very widely used in industry because in industry you do not need to always measure something, a certain parameter. So you don't need to measure a distance. There are fixed distances. You just need to know whether the object is there or it is not there. You just have to sense the presence of that object. So these sensors are very reliable. They need to have a long life because they are installed on machines which are supposed to work for 5 years or 10 years. So there can be various types of proximity sensors. It can be an optical proximity sensor. It can be a can say ultrasonic proximity sensors, or it can be an inductive, or it can be capacitive. It can be based on infrared. Any sensing technology can be used, and there is a wide range of sensing technology available for this type of sensor. So a proximity sensor, how it works? So it is a very simple operation. It will send a signal, and if there is an object, the signal will get reflected and the proximity will be detected. And if there is no object, then the signal may not get reflected. So if the signal is not reflected, then the output is negative. And if the signal is reflected, then the output is positive. So there are different types of proximity sensors, and one of the common proximity sensors is inductive proximity sensor. So what it does is that it is giving out electromagnetic signals, and if there is an object, so if there is a metallic object coming near an inductive proximity sensor, the electromagnetic signals will generate a flux in the metallic object, and that flux will give out more electromagnetic signals, or you can say it will give out similar electromagnetic signals back to the proximity sensors. And when these electromagnetic signals are returning to the proximity sensors, it will generate an output. But the problem with inductive proximity sensors is that it will not work with non-metallic or non-conductive objects. So if you put your hand in front of inductive proximity sensors, you will not get an output. So these are only used in environments where only metallic objects are to be sensed. Plastic objects are not present. But on the other hand, there are capacitive proximity sensors. So what they do is that they measure the capacitance between the object and the sensor. So if the object is coming within its range, a capacitance is generated, and the capacitance, if it is more than the threshold value, then it will generate an output. And if it is less than the threshold value, it will not generate an output. So it depends on the capacitance generated. So in the capacitive sensor, it doesn't matter if it is a plastic or it is your hand or it is liquid or even it is metallic. So any type of object can be sensed using capacitive proximity sensors. So these are some of the diagrams. You can see in the inductive proximity sensor, it is giving out some electromagnetic field in its sensing range. And if a metallic object comes within the range, the signals will be reflected or there will be additional flux generated. So when an additional flux is generated or the object sense, and there is a change in the current which is flowing in the coil inside, and hence it will sense the object or it will sense the presence of that object. On the other hand, in the capacitive proximity sensor, it is depending on the capacitance between the sensor and the object which has to be sensed. So if the capacitance has increased, so capacitance depends on the distance between two objects. So if the object has come nearby, the capacitance will be more, and the sensor will generate an output. And if it is far enough, then there will be no output generated because the capacitance is very low. And the optical sensor, it depends. I mean, you can see it is a very simple operation. So there is an LED which will emit a light ray, and these rays, if there is an object, they will be reflected back to the photodiode in the sensor. So if an object is nearby, then the light will be reflected back and output will be generated. And if the object is very far, then I mean the light will still be reflected, but it will not reach the photodiode. It will get deflected in some other direction. So in this case, we need to calibrate the sensor depending on the distance. So the proximity sensors have a very short range, but optical sensors can have range, right? I mean, it can even have range in 100 meters, 200 meters, even 500 meters. Whereas the proximity sensors, the inductive and capacitive proximity sensors, they have small ranges, like it can be 10 mm, 15 mm, 20 mm, or maximum 50 mm. So they cannot work beyond that. So this is again an interesting sensor, vibration sensor. So vibration sensor, I mean, any sensor can be a vibration sensor depending on the range. So there are piezoelectric sensors. So piezoelectric sensors are generating signals depending on the, I mean, the vibration is converted into electrical signal due to the crystal inside it. So what happens in piezoelectric sensor is that the vibration is given to a crystal, and the crystal oscillates depending on the vibration. And when the crystal vibrates, a small electrical signal is generated, and electrical signal is measured. But in more precision applications, like in our mobile phones, we have gyroscopes, and accelerometers. So what these gyroscopes and accelerometers do is that they are measuring the vibration in X, Y, and Z direction. So ultimately, we will get a very precise information of vibration, whether it is in X direction, Y direction, or Z direction, or a intermediate direction. So depending on the application, we can select sensors. If we need to just measure the sensor irrespective of the direction, we can use a piezoelectric vibration sensor. But if we are interested in the direction, if we are interested in accurate direction and accurate quantity, then we are using the gyroscope and accelerometers. But why do we need? I mean, why is vibration sensor so important? Because I mean, we don't see any applications around us commonly. But in industry, what happens is that a machine is supposed to operate in a very stable manner. It is not supposed to have much vibration. I mean, every machine has its own vibration. But beyond that vibration, there shouldn't be any vibrations in the common operation. If there is an operation, it means that there is some fault in the machine. So in the current industry, vibration sensors have become very important, because what happens, by understanding the direction of the vibration, we can detect what is wrong in the machine. So that makes vibration sensors and so important. So we may have heard of this term known as preventive maintenance. So what preventive maintenance does is that it will measure all the quantity of the machine, measure the vibration of the machine, and before there is any fault, it will tell you that okay, there may be a fault in this bearing after 10 days. It will generate a trend of the vibrations, and it will detect that okay, this value may rise after 10 days, not today. But if it is rising after 10 days, you will get advanced, you will have a warning in advance that this may increase, there may be a failure. So they can do the maintenance, so they can avoid the downtime. So we had this project for Bharat 4. afford the downtime, vibrations. You need to understand the cause of vibrations so you can take preventive actions. So we're coming to drives and actuators. So these are the actual moving parts, you can say the mechanical parts of the mechatronic system. So what they do is that they will be the actual moving hands of the machine. These are the hands of the machine, you can say. The machine will not operate without these drives and actuators, because a machine with just electronics is nothing. It cannot perform any task. You cannot build a machine with just electrical and computer element. It needs to have drives, it needs to have actuators. So it can be broadly classified into electrical actuators, electromechanical actuators, and mechanical actuators. So electrical actuators are basically motors, valves, relays, everything that is only depending on the electrical signals and it is operating electrically. So these are electrical actuators. Then we have electromechanical actuators. So they have हो आता दिसते का स्क्रीन कोणती स्लाइड आहे आता sir am I audible and is the screen visible
Ah, Shubham, you are audible. Okay, and it
okay
is visible now. Drivers and actuators. Yes, you continue.
Okay. Sorry for the interruption. Yeah, so we will continue with drives and actuators. Yeah, so I was talking about drives and actuators. So you see, drives and actuators, these are the actual moving parts of the machine. So every machine has to have the moving parts. The machine cannot be just with electrical elements or mechanical, just with electrical elements or computer elements. It has to contain some mechanical elements which will drive the machine, which is actually moving. These are the moving parts of the machine. So these can be mechanical parts, these can be electromechanical parts, or these can be electrical actuators. But you can say actuator means something that is actually acting. So it can be broadly classified into three categories. It can be electrical actuator, it can be electromechanical actuator, or it can be a mechanical actuator, or you can say mechanical element. So electrical actuator means these are purely electrical elements. Purely electrical elements which do not have any additional mechanism. They are moving only on the electrical signals. So a classical example of electrical actuators is motors. There can be relays. There can be valves. Then we have electromechanical actuators. So electromechanical actuators are something which take electrical signal as their input and generate a mechanical output. So in solenoid valves, we are giving electrical signal as input, and the actual action is taken by, or it is done by, the pneumatics. So what happens is that in the solenoid valve, we are opening the valves with electrical signal, and the airflow and the actual motion is done by the compressed air in the pneumatic system. Then we have linear actuator, where it's a combination of motor and mechanical elements, where the motion is performed both by electrical and mechanical parts. So it is a combination of electrical and mechanical system. And then we have mechanical elements. So these are the cam-based or hydraulics. So you can see the first example, it is a servo motor. Servo motor is a very good example of electrical actuator because it is only working on electrical energy. It does not require mechanical elements for the motion. I mean, the motion depends on the electrical parts itself. Then we have relays. So these are the electromagnetic relays, electromechanical relays, you can say. Then we have solenoid valve. So what a solenoid valve does is that it is like a tap, but the tap is operated by electromagnetic cylinder. So which means, if you can say that if you increase the current, then the flow rate is increasing, and if you decrease the current, then the flow rate is decreasing. So that is how a solenoid valve operates. Then we have cylinders. So these cylinders, as I said, it is operated by electrical signals, and the actual functionality, it is performed by the pneumatics. Then we have cams. So you can see in the left corner, there is a classical example of a camshaft. So the profile, you can see it is not a round cam. It has a different type of profile. So that profile itself is the programming of that machine. So if you need to change the logic, if you need to change the operation of the machine, you need to change the profile of that cam. And then we have hydraulics. So as I said, hydraulics is widely used in applications where high amount of force is required. So this cannot be achieved by compressed air or electrical motors. So we need high amount of energy. So we are using hydraulic fluid, and we are pumping the hydraulic fluid into the cylinders. Yeah. So controllers. So you can say controllers are the heart and brain of every mechatronics system, because you cannot just have motors and cylinders and actuators and every mechanical elements working in their own. They will not work properly. either you will need to manually operate them or they will not work at all. So controllers come at action in this place. So what controllers do is that the control logic or the operation logic is written in the controller, and these controllers are controlling the entire machine, or they're controlling the system depending on the program or the logic written inside them. So there can be different controllers for different purpose. So there can be a controller for prototyping like Arduino, and there can be controllers in industry like PLC. So, I mean, many people may be wondering what is the difference between a PLC and Arduino, and why we are not using Arduino in industry, and why we are not using PLC in colleges and prototyping. The reason is that controllers like Arduino are made only for prototyping. They are not made for high reliability. They are not made for a specific application. They are not high performance controllers. So they will perform a task, they will perform it properly, but the performance required and the amount of reliability required in industry cannot be achieved by Arduino. So Arduino can be used for 100 different applications, but a PLC, it is designed for very specific application. So, I mean, you can say a PLC is around 1,000 times faster than an Arduino, but an Arduino can have more memory than PLC, but a PLC will have a very dedicated and a very specific application for its purpose. So what is an Arduino? So you may have heard about Arduino, and it is a very common hardware. I mean, every student uses Arduino in their projects because Arduino is an open source hardware and software company. So what they do is that they have generated this Arduino board using Atmega 328 processors, and it is a small processor, but it is a very powerful processor, and it has inbuilt ADCs, DAC, I2C ports, UART ports, and substantial DI and DOs. So it can be used for any prototyping purpose. Also, it has a USB for programming. So it has onload bootloader, it has onboard serial communication. So it is quite a powerful port, and the programming can be done using C or C++. And Arduino has its own programming software known as Arduino IDE, and it is very easy to program. And due to the reason it is open source, it makes it a very large resource community. So everyone is working on their own projects and sharing the projects with everyone around the world. So if someone needs to work on a particular project, he doesn't need to start from scratch. There will always be some reference material available with people. So Arduino is not just one board. There are different types of Arduino boards, right from this Arduino 232, which is a quite old version of Arduino. So before the USB technology became very popular, so this board was there. So the programming of this board was done via 232. Then we have Arduino Uno. This is the most common board used these days. So this has an onboard USB, and it is the latest board, you can say, and it is suitable for most of the purposes. Then we have Arduino Mega. So Arduino Mega has a processor, it has a larger memory option, and also multiple, I mean more IOs. So you can say this Arduino Mega is has 3 times more IOs than Arduino Uno. So in applications where you need to run multiple devices, where you have multiple stepper motors, you have servo motors, you can use Arduino Mega. Then we have Arduino Nano. So this is a very small, it comes in Then we have Arduino Duo. So Arduino Duo is ARM-based Arduino processor. So if you're requiring so if you require a larger processing power and better architecture, parallelism and all, so you can go for this board. And then we have this Arduino LilyPad, which is used in the wearables technology. So so in smart bands and fitness trackers, so this can be used for prototyping of fitness trackers and all these things. Yes, so we will talk about hello. कुठून जसं चालू केलं मी अजून प्रोग्राम ओके. Yes. So programmable logic controllers, or also known as PLC. So PLC is just like an Arduino, but only difference between PLC and Arduino is that PLC is made for a dedicated industrial task or industrial process. So the processor here is only made for that industrial task. It is not made for prototyping purposes. It may not be very versatile, but it has a very powerful processor, or you can say it is made for one task and it does it properly. So activities where high reliability is required, high accuracy, faster execution, PLCs are used at such places. Again, in PLC, we do not use programming languages like C or Python or such things. So here, programming is very easy so that fault can be detected easily. Because in industry, debugging should not take much time, because at more the downtime, there are more losses in industry. So advantages of PLC. So high flexibility. So in PLC, you do not have a conservative environment. So what happens is that one PLC is easily compatible with PLC of other make just by connecting two wires. So you do not need to add any additional hardware. You do not need intercompatibility, or you do not need different firmware. So these are very flexible. They're also very reliable. They have high performance, which means the instruction execution time of PLCs is in literally nanoseconds. So you can say a typical Mitsubishi PLC executes one instruction in 1.4 nanoseconds. So that is pretty high when we compare them with Arduino or even Raspberry Pi. The instruction execution time here is very fast. Low maintenance. So even though the controller of a PLC may be very small, every controller is just a small chip, but you may see that PLCs are very huge and very bulky. So the reason for this is that they are very toughened. So they have isolations, they have their redundant power supplies, redundant isolation, so that if there is a problem, you do not need maintenance immediately. So they have to have lowest amount of maintenance. They are so strong and they are so rugged that they require the minimum amount of maintenance. Then easy configuration and programming. So PLC programming is not at all difficult, and configuration of PLC and all these things are, I mean, they're very easy. So that can be done with a very small amount of training, because in PLCs, programming is not important. The important thing in PLCs is the logic that is implemented. So the programming language has to be as easy as possible so that the logic can be implemented efficiently. Also, the PLC system has to be easy to debug. So if there is a problem in a particular part of the machine, so they should be instantly, they should be able to recognize that there is a problem in this slide, there is a problem in this sensor, there's a problem in this output. So it should be easy to debug. So this is the general architecture of PLC. So as you can see, there is an input module, then there's an output module, but the CPU is always isolated from the input module and output module with the help of optocouplers or transistors or MOSFETs, so that even if there's a fault at input or output side, the controller should not get damaged. Then there's a power supply for PLC, because every processor works on, I mean, almost every processor works at 5 volt or 3.3 volt. So the AC supply 320 volt or 230 volts, or it may be 440 volts. This needs to be converted into 5 volts. So it has its own power supply. Then the programming of PLC is usually done on Ethernet. Ethernet, or it can be a USB. So the CPU needs to have a Ethernet card or a USB card. So this is the typical architecture of a PLC. So there are various types of PLCs. I mean, it can be a micro PLC, which is used for compact spaces. So where the processing requirement is not very high, but there are small spaces. We can use micro PLCs. Then there are these high performance modular PLCs where large amount of programs, I mean, large instructions can be executed. Multiple machines are to be controlled. You can see that what entire plants can be controlled using this one system. So this is a modular approach. So if you need to change something, you don't need to change the entire PLC. You just need to add or remove a particular module. Then we have HMI plus PLC. So in small applications where we need to display something, we need to take input from the user and display something to the user, we use HMI plus PLC. They are also known as GOC, Graphic Operational Controller. Yeah, so this is the programming of PLC. So there's a standard known as IEC 61131. So this standard defines the structure of PLC programming software. So most common types of PLC programming languages are ladder logic. Then we have the functional block diagram. We have structured text. Structured text is just like programming in C. Then we have instruction list, and then we have sequential flowchart, which is like the flowcharts we are making. So ladder logic is, I mean, the reason we are using ladder logic is that it is, I mean, we can directly correspond the ladder logic with hardware. So it is like you are making a hardware circuit in the software itself. So you are making a hardware interpretation of the logic, and then you are simulating the logic just as the hardware should work. So you can get a better feel of the machine. You can program efficiently, and it is easy to debug. So these are in ladder logics, you have timers, counters, and as inputs and outputs, we have coils and contacts. So in this, you can see this is these two things, key switch 1 and key switch 2. These are the contacts, and door motor. This is the coil. And again here in the OR, this is the contact and this is the coil. So it is just like programming different types of gates. So it is a very easy way of programming. PLC programming is not at all difficult. It's a very easy and reliable programming software where logic is more important than the programming. So this is a simple architecture of any mechatronic system or industrial system where there is a PLC or controller. Then there are the drive elements. It can be a motor, it can be a robot, it can be slide. Then these drive elements are working in a machine, and various sensors and vision systems are continuously monitoring different parameters, continuously sensing inputs and giving the feedback to the PLC. So generally every mechatronic system has to be a closed loop system for the efficient operation. So this is the simplest architecture, you can say. It is a closed loop architecture of a mechatronic system. Then again, robots are the new trend in industry. I mean, actually, robots are there present in industry for over 40 years. But in India, robots have become popular in the last 10 years. People have started to automate their factories with industrial robots because robots can perform the same task repeatedly for 24 hours, 7 days of a week without taking a break, and their accuracy is never changing. So humans may get tired and their accuracy, their efficiency may decrease, but robots never get tired. So where high accuracy, repeatability, and speed is required, people have started to use robots. So these are some of the example of industrial robots. So there is a Gantry robot, which is a Cartesian robot. So it is just like XY axis. So there are slides connected orthogonally to each other, and the robot is operating just like in XY plane. Then we have SCARA robot, which is known as the selective compliance articulated robot. So in this, what happens is that there are multiple axes connected, and this is for high speed application. Then we have the articulated robot, which is the 6-axis robot. Then we have Delta robot, which is a 3-axis robot, or it can be called as a parallel robot. And then we have AGVs. So AGVs are automated guided vehicles. So in large warehouses like Amazon, Flipkart, Alibaba, then we have courier service providers like DHL, DTDC. All these service providers have AGVs installed in their factories, which means these AGVs are automated robots, automated cars, you can say. So these cars are moving from one place to another, carrying loads, carrying packages from one place to another, from one conveyor to another. So places where there are large warehouses, large storages, or godowns, you can say. So in these godowns, there are 500 of these AGVs. So all these AGVs are replacing humans because they are working extremely fast. They are not making any mistake, and over the period, the cost of robots is always less than the cost of humans. So some of the application of industrial robots. So robots are used for welding. They are used for assembly. They are used for dispensing, painting, palletizing, material handling. So everything that used to be done with humans, now it is being replaced by robots because robots are efficient and they never make mistakes. So yeah, that's about it. So I'll talk about my company, what our company does. So we are working very closely with most of the large automotive companies. So what our company can do for students, that we can provide training, we can provide internships, then sponsorships and industrial projects is again one more thing. So we have been sponsoring projects for past 2 years, and we're giving many students an opportunity to work closely with industry, see how things are done in industry, and work on live industrial projects. We can give support in lab development, support in curriculum design, and if you have any requirement, you can contact us. So I will just show you a small example of training kits which we supply. So these are the PLC training kits. So this is a PLC, HMI, switches and all. So it is a very good way to understand how PLC works, how different industrial components work, and how their programming environment is actually working. So this is a mechatronic training kit. So you can see there are multiple mechatronic components like servo motor, there is a linear slide, there are pneumatic components, there is a conveyor, there are different types of sensors, there is a linear indexer, HMI, and all these things. So it is a very good way to understand how the real system works. So this is an example of a machine, but it is made in such a way that students can program it, students can understand how it works. And again, these are some of the attachments. So there are different components like relays, we have MCBs, MCCBs, MPCBs, contactors, various sensors. So again, a small example, and students can better understand how things are working. And this is for modular PLCs. So for the training of high performance PLCs, this kit can be used. So that's about it. And I will like to hand over to Shirode sir so that they can conclude this session from my side. Thank you very much for your attention. If you have any queries, you can either you can email or you can ask it in the uh, chat box. And if you have any inquiries, if your college needs training kit, you can note down the email ID and you can write to us. We can supply customized training solutions for you because recently we have started lab development with PCCOE. We have also supplied some lab development equipment to colleges in South India, colleges in Coimbatore, Chennai, and even in Sant Gajanan Maharaj College of Engineering in Shegao. And we are working closely with many institutes, and one of them is PCCOE. So I would like to thank you for your attention, and any queries are welcome. Or if you do not have any queries, we can conclude the session.
Hello,
Yes, sir.
hello, hello.
Yes, sir. You're audible. Perfect.
Thank you, Shubham, for giving us such a brief knowledge about PLCs and sensors. So I think all participants would like to contact you further for their lab development under mechatronics and PLC. And it will be helpful for all of us further in the further journey of this development of education system. So thank you very much for being with us and delivering such a wonderful session.
Thank you for the opportunity, sir. Thank you.
Thank you. So audience, all of the attendees, you can thank you for joining today. How you like today's session and what is your views with this session? You can share using feedback forms. So feedback form link will be shared in a short while through the WhatsApp group and the Telegram groups. Thanks for joining us. We'll meet tomorrow again with a new session, with a new day, and with a new area. of electronics domain. So have a nice day. Stay safe. Thank you.